Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 1, real numbers and algebraic expressions. In the previous videos, I believe we covered most of the topics related to real numbers and some basic informations about algebraic expressions. But in this section, 1.4, we're going to focus on properties of real numbers and algebraic expressions. So the objectives for us is to use operation and other symbols to write mathematical sentences. We're going to identifying identities and inverse using the commutative, associative, and distributive properties, using the commutative, associative, and distributive properties. I said it twice, and simplifying algebraic expressions. In terms of algebraic expressions, algebraic equation is a statement that two expressions have equal value. So we said, is that if you go directly with the definitions of equations, equation is a statement that two algebraic expressions are equal. If you have an equal sign, or it says gives, is means equal, yields, amounts to, represent is the same. So they are all algebraic equations. So if we have 2x plus 5 equal 12, for example, 2x plus 5 equal 12, because we have that equal sign in the middle, that means it's an equation. If there was no equal sign in the middle, let's say, for example, this one is an equation because there is an equal sign. But if I have 2x plus 7 plus 3 times 5x minus 1. So with no equal sign, we can consider this one as as an algebraic expressions, but not an equations. So this is the difference between algebraic expressions and algebraic equations, or equations in itself. See for some example, write each sentence as an equation, because what you need to verify here is the is. Is mean equal, right? Is means equal. So the difference, the difference means negative, right? So the difference of 7, this is the difference, and a number, what is that number? We don't know. Anytime they said a number, you can represent it by a variable. We already covered variable. Variable is a value that we don't know. So we can call it X, you can call it A, you can call it Y, Z, W. I mean, they said the difference of 7 and a number, the number we don't know, is mean equal 42. See, the quotient of y, quotient, remember, quotient means, when we talk about quotients, what quotient means again? Divisions, right? Quotients mean division. So we said the quotient of y and twice x, twice, what twice means is 2 times x. So twice x is mean equal, is the same as the product. Product means multiplication. Remember, product means multiplication. Is a product of 4 nz's. That means 4 times z. So you see, this is how you can translate sentences into a mathematical model. So there are some symbols you can always look for in terms of equality and inequality symbols. So equals here, A is equal to B, A is not equal to B, A is less than B. Those are inequality. Okay, I mean, all of these are inequalities, all right? It's either equal or inequalities, all right? So you can have A less than B, A greater than B, A is less than or equal to B, A is greater than or equal to B. Not all the time you're going to find them that easy. Sometimes they say A is at least B, okay? Or is no more than B. So you can find it is at most B. Does it exceed B? There's a different ways of expressing inequality. So for other properties or for real numbers, for any two real numbers, A and B, A is less than B if A is to the left of B on a number line. Let's say, for example, if I have two numbers, the remember 0 is here, right? If I have 1, 2, 3, 4, if I have 4 here, obviously, if we have A here, B here, obviously, A is less than B, right? On a number line where 0 is in the middle, if I have negative 3 here, I call it B, and I have, remember A for us is like a variable, but we can say A is really greater than B because A greater than B means A is to the right of B. Very important. Let's see that putting some symbols in this example. Insert less than, or this one is greater than. Okay, -6. Is this less than 6? Yes, less than. You see here it's greater than. Now, -12 and -8, the bigger is the number with a negative sign, that means the value is smaller. So that means -12 is definitely less than -8. You have -2.7 is definitely less than -2.2. Now, at some point, you need to look at the decimal. You compare the decimal. After you compare the whole numbers 8, 8, you can compare 2, 2 after the decimal point, 5, 5 after the decimal point. But this one doesn't have 0, but this one has 0. Even though you add a 0 after that, at the thousands, it doesn't change anything. So that's why the symbols for this one is equal, right? Now, there is no way that -7/8 would be greater than 0. So 0 is way bigger because on the number line, you're going to have 0 here on the right, and you're going to have, if -1 here, so probably you're going to have -7/8 somewhere here. Now, we can continue with some other example by translating each sentence into a mathematical sentence. We said the difference of 7 and x, the difference, remember that's difference means minus, the difference of 7 and x is less than or equal to. Less than or equal to is that one, right? Less than or equal to 21. We just try to translate. 9 is not equal. What the symbol for is not equal is this one, to x plus y. Mathematics is not only numbers and letters. Sometimes we can express mathematics in words. So, construct a complete sentence. 30 is greater than is that symbol, then the sum of 9 and x squared. You see, as I'm reading, I'm writing also the mathematical expressions for it. Now, how to identify identities of inverse? Well, I think that's very important also. For any real number A, identity property of 0, adding 0 to any number, like 5 plus 0, that would be 5. 0 plus 12, that would be 12. But you also can say, do like negative 15 plus 0, it would be negative 15. 0 has no impact on it. How the identity for 1, but let's say, for example, here you see 8 times 1, that means 5 times 1 is equal to 5, right? 1 times 7 is equal to 7, for example. But remember, 5 times 0 is not equal to 0, it is not equal to 5, it's equal to 0, right? So we went over those properties already. That's identities. We also have opposite or additive inverse. If A is a real number, then the unique opposite or additive inverse of A is written as negative A, and the following is true. So if we have A plus negative A, we said it's equal to 0. Like if we have 5 plus negative 5, for us, it's the same thing saying 5 minus 5 is equal to 0. If I have $5 and I spend that $5, I have none. Double negative is different, because if I have 6 minus negative 3, because these two negatives follows, as we said, you can convert two negative into addition when you deal with multiplication. So it becomes 6 plus 3, it's equal 9. So you have nothing in negative, and you don't really do a subtraction for it. So we call it double negative properties. Let's see what we can have here. Find the opposite or additive inverse of each number. For 9, what would be the opposite? Is what? Yes, negative 9. How about opposite of negative 1/8? Yes, positive 1/8. How about opposite of 0 is 0, because 0, negative 0, positive 0 doesn't make any effect on it, so we're gonna just keep it like that. So properties of real numbers also, a real number, reciprocals of multiplicative inverse. If A is a non-zero real number, then its reciprocal or multiplicative inverse is 1 over A, and the following is true, right? So if we want to know, for example, if you have 17, reciprocal is, you just flip it. Reciprocal is, you flip it, just flip it, okay? So that's gonna give you 1 over 17. Okay, so that's it. If you have negative 3, reciprocal for negative 3 is negative 1/3, right? If you have reciprocal, if you have 2/3, reciprocal, it's just flip it. You need to flip it. Reciprocal 3/2. Okay, we're gonna continue that way and see if there's any more example to do. Find a reciprocal of or multiplicative inverse of each number. So the first number we have here is 11. What's the reciprocal, please? Reciprocal is 1 over 11. The next one, you can write it down or you tell me. Yes, negative 1 over 7. It doesn't matter where the negative goes. All right. So how about for this fraction? So what would be the reciprocal for it? All right, you got it correct. Now, properties of real numbers, we have we need to learn also how to use commutative, associative, and distributive properties. Commutative properties for any real numbers A and B, A plus B equal B plus A. For example, 2 plus 5 is the same, 2 plus 7 is the same thing saying 7 plus 2, answer would be 9 in terms of addition. But if you do multiplication, if you do 6 times 3 is 18, but 3 times 6 is also 18, right? Answer would be 18 because it's commutative. You can switch it. The associative properties states that the regrouping numbers that are added or multiplied does not affect their sums. So when we say about associative, look at that. So if I have 2 plus 5 plus 3 is the same thing saying 2 plus 5 plus 3. So both would be equal to 10. So it doesn't matter how to do it. If I do 3 times 7 times 2 is the same thing saying, I can do either one of these. So I can do 3 times 7 times 2, both would be, because it's gonna be 42, all right? So we have all those examples. You see, I put a few examples for you just to see, but I'm gonna do examples directly. Let's say use commutative or associative. For commutative, the first one would be what? Yes, 8 plus x. It's just to show you that you can do x times 7, okay, multiplying, and that's associative. That means you can do 3 plus 8 plus 1. You could do also 3 plus 1 in parentheses plus 8, or let's say here you can do minus 5 times 4 times 2. Answer would be the same, or you can say x times 18 y. Answer would also be the same. There is no change of that. So that's for a commutative and associative. One of the most important properties of real numbers you need to always bear with you and remember of all time is the distributive properties. For real numbers, A, B, C, having A, you need to distribute. That means you do A times B. That gives you AB. A times C, because there is a plus in the middle, that gives you AC. For example, if I have 2 times x plus 3, the first thing to do is to multiply, distribute the 2 with each number inside. So we're going to have 2 times x, give us 2x, and there's a plus sign in the middle, and we do 2 times 3, 2 times 3, so answer would be 2x plus 6. The distributive property, that's something we're going to use all the time. But even for the sign, if you have 5 times 2y minus 3, okay, when you distribute, you do 2 times the whole thing here. That gives you 5 times 2y minus 5 times 3, okay? 5 times 3. So that's 5 times 2y give you 10y minus 15. You can distribute it this way also, and that's going to make a big change. Let's see a few examples. Here, we can distribute with this one. That gives you 7x. And 7 times 4y. Remember, you multiply the real numbers with the real numbers. 7 times 4 is 28, and y. You multiply real numbers. Remember, with that negative, it's very important to know that you do 3 times negative 5 plus 3 times 9z. Now, 3 times negative 5, a positive times a negative give you negative 15. 3 times 9, remember, you must multiply the real numbers together. That gives you 27z by itself. Now, I would like you to see the difference here. There is a negative in front of the parentheses, but no number like greater than 1. So what you can see, either this negative sign outside of the parentheses change all the values inside of the parentheses, or you can say -1. The 1 is always invisible. You don't see it, but it's there. You can say -1 times 8 plus x minus w. If you distribute that negative, now you can have -1 times 8 plus -1 times x plus -1 times -w. When you distribute, it gives you -1 times 8 gives you -8. -1 times x gives you -x because plus and minus give you -x. 1x is x. And 2 negative, you see -1 times -w. 2 negative give you positive 1w. We can just write as w. Right? I know there is so many examples we could do that way, but let's enjoy this one for now. That's very important. When we ask you to write each as an algebraic expression, here we try to write algebraic expressions as one of the objectives we're pursuing in this section. A vending machine contains x quarters. You know x quarters, what would that be? What is a quarter? So a quarter is, how much money is a quarter? Yes, 0.25 cents. We can always say 25 cents, all right? So x quarter. So what is x quarter? Instead of us writing x quarter, you agree you can write an expression for the value of the x. We don't know how many, so it's x. So quarters is 0.25x. And that's it. That's what they ask you to write down. The cost of Y tables, if each table costs $230. So one table costs $230. So Y tables would be 230 times Y. And that's it. We have so many examples like this. So how to write algebraic expressions. Two numbers have a sum of 40. Two numbers have a sum of 40. If one number is A, represent the other number as an expression of A. Okay. If you have $40 and you give someone $10 from it, how much money you have left? Yes, you have 30 left. The reason why you do that, you take your 40, you subtract 10 from it, and you have 30 left. Now, suppose you don't know how much you give away. You give only a value. So you have $40, you give a amount of dollars from it away, all right? That's what you have left. You have 40 minus A. Now, if A is 25, then you have only 15 left. If A is 10, you have 30 left, etc. So that's how we're gonna continue to write expressions. Two angles are supplementary if the sum of the angles is 180 degrees, right? 180 degrees. If the measure of one angle is x, degrees represent the other angle as an expression of x. So you have 180 degrees in total. If one number is x, you need to subtract it from the total. So this is the value for the rest. So once you know what is x, you can substitute it. Let's say if one angle is 60 degrees, then you know the other one will be 120. Another objective to pursue in this is really to simplify algebraic expressions. To simplify algebraic expressions, you need to understand like terms. Terms of an expression are the addends of the expressions. Like terms contains the same variables. Let's say if I do 2x plus 5x minus 1. Now, you see, I keep my 2x, plus if I distribute 5 times x, give me 5x. 5 times -1 give me -5. Now, like terms means I combine those with the x's together. I combine the constant together. Because I have two expressions with x, I can add these two. So 2x plus 5x give us 7x minus 5. The 5 stay alone because there is no other constant to combine it with. Let's see some examples. Here we have 3x minus 5x. First of all, because both of them has x, you can subtract the coefficient. So 3 minus 5, that gives us negative 2x plus 7 because you don't have nothing to combine the 7. Now, you have x and x, you can combine the coefficients. So 8 plus 10 give you 18. Now, we're done with the x terms. Let's go with the constant. We have negative 8, negative 3. When you have two numbers with the same sign, we add and keep the sign. So we're going to have negative 11. Two numbers adding with the same sign, we add and keep the sign. If they were different sign, we subtract and keep the sign of the largest number. Okay, I think we went over that already. Other examples to follow in this one, let's say here also, we have 7 and 3x, so both of them has x, so that means you can do a negative 7 plus 3, that gives you negative 4. You subtract and keep the sign of the largest number with x, and you combine the constant where you have 5 minus 2, that gives us 3. For that one, we have 3y, we have y, and y, but there is a 1 in front of the y. For us, it's like we have 3 minus 2 plus 1. Let's give it 3 minus 2 is 1, 1 plus 1 is 2, so we're going to have 2y. Now, the other thing you see is negative 7, negative 5. So when you have the same sign, you add and keep the sign. So minus 12. If you feel like I go a little bit too fast, I strongly advise you to review, to pause the video and look again, because we're going to do a lot of examples. Simplifying simplify expression using distributive properties to multiply and then combine like terms. For example, here, look at that. You have negative 5 in front of the parenthesis. You need to do negative 5 times the first term because we're gonna keep order of operation. We need to do parentheses first. So negative 5 times x squared. We're going to do the same thing also with negative 4 plus negative 5 times negative 4. So 7x squared, we don't do anything with it now. We have negative 5x squared. Two negative become positive, 20. Now combine 7x squared, 5x squared, give you what? 2x squared. You got it. And now, if you look at the constant term, 3 plus 20 is 23. All right, that's a beautiful example. Now, last one, I can do it or I can let it for you to do. First of all, order of operation, PEMDAS. Always go with parentheses. We're going to distribute because we cannot add 4a to 4b, or we cannot subtract them because a and b are not equals. We need to distribute. That means you do 1/2 times 4a. You distribute the 1/2 also with the negative 6b. We're done with the first parenthesis. Let's go with the second parenthesis. We do negative 1/3 times 9a, negative 1/3 times 12b, negative 1/3 times negative 1, and we have 1/4 at the end. Remember, do not multiply the negative 1/3 with the 1/4 because the 1/4 is not inside of the parenthesis. Now, let's simplify. We have 4a over 2 plus, 1 positive, 1 negative become negative, negative 6b over 2 minus 9a over 3 minus 12b over 3. 2 negative become positive, 1/3 plus 1/4. Now let's simplify. You see 4a over 2 give you 2a. 6b over 2 give you 3b. 9a over 3 give you 3a. 12b over 3 give you negative 4b. Now, if you want to go somewhere and show that if you have a fraction plus another fraction. So 1/4 plus 1/3 plus 1/4, you need to find the least common multiples. What number divide 3 and 4 at the same time? So we know 3 divide 3, not divide 4, 6 divide 3, not divide 4, 9 divide 3, not divide 4, 12 divide 3, and divide 4. So we're gonna go with that number because 8 divide 4, not divide 3. The first number that divide both is 12. So the least common multiple is 12. That means we need to multiply this one by 4. By whatever you do with the bottom, you need to do it also with the top. That's give you 4 over 12 plus 3 over 12. That's give you 7 over 12. So we go back here, we add 7 over 12. Now let's finish it. We can conclude that 2a minus 3a give you only negative a. And negative 3b minus 4b give you negative 7b plus 7 over 12. And that should be your final answer for these examples. I hope this helped you to do more exercise from the book. We're going to come back ASAP with something different about, chapter 2. We're going to have fun with chapter 2, where we would cover especially equations, inequalities, and problem solving. Hope you have fun. Let me know if you have any questions. Take care.